Hi everybody, it's Mrs. Tellas. We're going to do the last section in Chapter 8. We're going to decide based on points given and tables whether a function is linear, exponential, or quadratic. So we can tell by a picture or we can also tell by a table. And you'll see a pattern emerge as we do that. Okay, so what does the graph of a linear function look like? Well, we all know that a linear function is a line, a straight line. Okay, normally we do that in the form of y equals mx plus b, or standard form ax plus by equals c. Okay, so we know what the line looks like. I mean, we could draw one. The only one that's not a function is a vertical line. Okay, all of their lines are functions. All right, and what does the graph of a quadratic function look like? A quadratic function is what we've been working on in Chapter 8. So it's a parabola. We know what it looks like. Okay, or it could be this way as well. Okay, we know standard form for a quadratic is y equals ax squared plus bx plus c. Okay, you know you can take the bx out or the c. You need that squared though on the x. Okay, and then for an exponential function, we did this a while ago. The parent function of that one, looks like y equals ab to the x, where x is in the exponent. So we can tell, and remember it will always either approach the x-axis, but remember it will never touch. It could also go this way, or it could come up from below. Or it'll always be approaching some imaginary line. And in most of our examples, they were approaching the x-axis. Okay, so we've got some pictures here, much better pictures than mine. Linear means a line. Exponential means this curve that will be approaching x-axis. And the quadratic function is that parabola. And that is not a picture of the parent function. Okay, it's got the bx and the c, so it's off the side there. Okay, so if we go through these real quick, we should be able to tell whether linear, quadratic, or exponential. And I'd like you to press pause right now and write L for linear, Q for quadratic, and E for exponential to make sure you can recognize what each of these are. Okay, so if we look at the first one, that's already in slope-intercept form. That one's linear. If we look at the second, it has an exponent of x, so that is exponential. This one has got the 2 here, which means it is quadratic. This one has the x in the exponent, that is exponent or exponential. This is in standard form as a quadratic. It's got the x to the second power, and this is linear. Notice that I've got h of x and g of x and y and f of x. Remember, those all mean the same thing and are completely interchangeable. All right, so if we look at number 1, it says to plot the points and tell whether the points appear to represent linear, exponential, or a quadratic function. So let's go ahead and plot. So 4, 4. 1, 2, 3, 4. Up 4. 2, 0. 0, 0. So we can already tell that that is not a straight line. It's curved. And we have 1 negative, actually we have 1 negative 1/2, so like right here. And negative 2 up 4. 1, 2, 3, 4. Oh, that makes a parabola, doesn't it? Here we go. Okay, so this is a quadratic. And if we look at B, we've got 0, 1, so up 1. 2, 4 is right 2 and up 4. 4, 7. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. Negative 2, negative 2. And negative 4. 1, 2, 3, 4. 1, 2, 3, 4, 5. That is a straight line. That is linear. That is linear. And we've got one more example. My guess is it's exponential. But let's pull it down here because it's kind of not, doesn't have its own graph yet. Let's give it a graph. Okay, so here we go. So my guess is this one is the one that we haven't done the others for. I think it's exponential. So 0, 2, 2, 8, 1, 4, and negative 1, 1. Yeah, that's a curve. It's not crossing the x-axis. This is exponential. All right, very good. Okay, so if they give you the points, graph them and see what it looks like, whether it's linear, exponential, or quadratic. All right, now let's look at tables. Well, you could still, if like say this is the test, you know, in the 10th grade and you can't remember what the rule is, feel free to graph those points. That'll give it to you. But there are patterns that we're going to discover together here, and I'm hoping that you see them. So you can see on the x that this is just increasing by 1 each time. I think it's always going to be like that, at least for the examples that we're doing. But down here, you can see that it's not just increasing by 1. So let's look and see what the pattern is. So it looks like from 11 to 8, we dropped down by 3, again by 3, dropping by 3, and by 3. So this actually has a slope. The slope here is negative 3 over 1. This is linear. This is linear. It's got a minus pattern. Okay, across the y. Let's look at B. Okay, same thing for the x-axis. It's just increasing by 1, just like those graphs were that we were doing before. But down here, let's see what the pattern is. So it's a plus 1, but that's a plus 2, plus 4, plus 8. It doesn't have a plus pattern. Okay, so let's try maybe a multiply pattern and see if we can find a multiply pattern. So if I multiply by 2, by 2, by 2, by 2, hey, it's got a multiply pattern. So that means that this is exponential. Okay, and the pattern is multiply by 2 in the y and add 1 in the x. So it's exponential. Okay, and then if we look at C, okay, so what I notice here, this is all by 1 again on the top and the x-axis. But here, I've got something funky going on. So let's see, I'm adding, or actually I'm subtracting 1, I'm adding 1, I'm adding 3, and I'm adding 5. So it does have kind of a pattern, but it's not linear, and it's not exponential because there's no multiply. Let's try a multiply pattern and see what we can find here. So from here to here, we would have to multiply by negative 2. From here to here, we'd have to get into the fractions, wouldn't we? Or divide by 2. Yeah. Here we could multiply by negative 2. And here we'd have to multiply by 3.5. Okay, so it's definitely not exponential, because if it were, it'd be multiply or divide all the way across by the same number. So if you notice, the pattern that we were looking at before, it's not an add, which would be linear. It's not a multiply, which would be exponential. So it has to be a quadratic. Has to be. That's the only thing it can be. If you also notice that these two are the same, this one and this one, which means this one is the vertex. And then if we went back some more, we could figure out what the other ones are. So negative 3 would be 2's partner, and negative 4 would have a 7 partner, because these two would match and these two would match. So we could go back further and figure that out if we wanted, but we certainly don't have to. We certainly don't have to. All right, this is number 3, so it's the second number 3, because number 3 was just on the last page. So let's try this one, linear, exponential, or quadratic. You press pause and give that one a try and see what you come up with. All right, so you can see in the x that it's plus 1 all the way across. And then down here, I'm thinking multiply, because if I add 2 here and I add 2 here, I don't get 9. So let's try multiply by 3. Multiply by 3, multiply by 3. Yep, that is the perfect pattern. This is exponential. And I know because it's got a multiply by 3 pattern on the y. Okay, number 4, linear, exponential, or quadratic. Now across the top, I've got plus 2 this time. Plus 2, plus 2, plus 2. And that's okay. Just because it's not plus 1 doesn't matter as long as your y is consistent. And x has to be consistent as well. So let's see here. I'd have to go minus 12, and then minus 4, and then plus 4, and plus 12. Ooh, do you see that pattern? Okay, it's definitely not exponential. I'm not multiplying by something all the way across. I'm not adding by something all the way across. But do you see that these two match, these two y's, and that these two y's match, which makes this one the vertex. So this is a quadratic. This is a quadratic. You can tell because of that pattern. The same patterns that we look for when we do our tables. So if you want to write down the patterns, if you want to put them in your notes, you know something's linear if it has a plus pattern for y. And you know something's quadratic if you can figure out, actually exponential is easier. Let's do that one first. It has a multiply pattern for y. Okay, in quadratic, we always want them to match. So we want that vertex here in the center or somewhere. And then we'll have these y's match and these y's match. And we'll be able to figure out from there. So you're looking kind of for matching numbers on the bottom, and then you're trying to figure out what the numbers are that make them quadratic. Now you can also have a minus pattern here. That just means it's negative. And you can also have a divide pattern here. Because multiplying by a fraction is the same as dividing by a whole number or an integer, depending on the sign. Okay, so let's take a look at number 5. So across the top, I'm adding 1 all the way across. Whoops. Adding 1 all the way across, which means it's a constant up there. And then down here, let's look. So I'm subtracting 8, but here I'm not subtracting 8, so it's not linear. I'm dividing 2, or I could say I was multiplying by half. That's the same thing. So this one is exponential, and I can tell because I'm either dividing by 2 or I'm multiplying by half. Whichever makes you happy, it's the same thing. I hope you're catching on here to this pattern. Ooh, this table is very not that nice. Let's go ahead and look at it. Okay, so across the top, looks like I'm adding 1. Down here, I hope you see that it's 0. I'm adding 0.5 each time. 0.5 plus 0.5. This one's linear. This is linear. It's got a slope of 0.5 over 1 or just 0.5. Okay, let's look at this one across the top. I'm adding 1. Down here, looks like I'm multiplying by 4 maybe? No, by 3. Multiply by 3. Multiply by 3, multiply by 3. This is exponential because I'm multiplying by 3. Okay, so your assignment is on page 465. It's actually in Big Ideas, so I believe it's 4 through 18 all, and this is the last assignment in Chapter 18. I'm thinking about having a big quiz. That first quiz didn't work out very well, so I couldn't see any of your scores, so I messed something up. I'm not going to have you retake it, though. We'll just do a big quiz over everything at the end. So I hope things are going well for you, and if you have any questions, email me, and remember I'm online every day from 12 to 1 for your class. A couple of you are taking advantage of that, but not everybody is. And I'm happy to help you if you need it. See you later. Bye.